let's look at the Lewis structure for CH₃F. Lewis structures are not just about dots and lines. They are actually about making atoms happy. So the first step to do is to count how many electrons does everyone want. So for carbon, it wants 8 electrons. So we have 3 hydrogens which wants 2 electrons each. That will be 6 electrons. And then we have 1 fluorine atom which also wants 8 electrons. So if you add all these electrons together, you will get 22 electrons. So the next step to do is to find out how many electrons the atoms actually have, which is to say how many valence electrons does each atom has. So let's see from the periodic table. So we have our group 1, 2, let's skip the transition metals, 3, 4, 5, 6, 7, and group 8. So counting the valence electrons, hydrogen has 1 valence electrons, right? So 3 hydrogens will give you 3 valence electrons. From the periodic table, carbon is in group 4. So carbon will have 4 valence electrons. Fluorine is in group 7. So that will give you 7 valence electrons. So you can actually think of valence electrons as money, okay, like currency. Some atoms are rich, they have so much money, they have so many electrons, right? And some other atoms are broke, they don't have money or they don't have as many electrons. So if you sum up all these valence electrons together, you get 14 electrons. Bonding electrons will be 22 minus 14, which will give you 8 bonding electrons. And as we know, whenever we draw a stick or a line, it has 2 electrons. So to find out how many bonds or lines we have to divide 8 by 2, give you 4 bonds. The next step to do is to draw the skeleton. Carbon loves attention. Carbon will be at the center, and it also has many bonding spots. Okay, it is the less electronegative compared to fluorine. So you draw the 4 bonds around the central atom, which is the carbon, and then attach the 3 hydrogens and then 1 fluorine. Each single line represent 2 electrons. So now let's check the happiness level. Hydrogen only wants 2 electrons, and the single line means they have 2 electrons. So it means that hydrogen is happy. Carbon wants 8 electrons to be happy, and carbon already has 4 single bonds around it. So that means carbon also is happy because it has an octet. How about the fluorine? The fluorine also needs 8 electrons, but currently the fluorine only has 1 bond attached to the carbon, which is only 2 electrons. So the fluorine is not happy. How do we make the fluorine happy? To make the fluorine happy, we have to give the leftover money to fluorine. So leftover electrons will be 14 valence electrons minus 8 bonding electrons will give you 6 non-bonding electrons, and 6 divided by 2 will give you 3 lone pairs. So add all those 6 electrons as dots around the fluorine atom. So we'll add 2, 4, 6 non-bonding electrons around the fluorine. Here is a tip to keep your drawing neat. Imagine that this fluorine is in an imaginary box, and then you place the lone pairs around the fluorine, and each side of the fluorine can only take maximum of 2 electrons. So now let's do a quick bank check. Carbon already has 8 electrons, we've seen it. Hydrogen has 2 electrons because it only needs 2. Let's count the number of electrons around the fluorine. We have 2, 4, 6, and 8. So now fluorine wanted 8 electrons, and now it has 8 electrons. That means fluorine is happy. This will be the Lewis structure for the compound CH₃F. So for an illustration, these are the 4 bonds, these are the 3 lone pairs, The white balls will be the 3 hydrogens, the black ball will be the carbon, and the blue ball will be the fluorine atom. So you stick all the 4 bonds around the carbon and then attach the 3 hydrogens to the other ends of the bonds. Then add the fluorine atom. And then the lone pairs, we have 3 lone pairs, which is 6 non-bonding electrons. All of them will go on the blue ball, which is the fluorine atom. So this will be the Lewis structure for the compound CH₃F.